Hey guys, this is going to be a quick video over slope of tables for your 3C-6 notes for slope of a table. I do want you to pause your video real quick and to write this down. Rate of change is another way of saying slope. We already know that. That's what we know. We have been trying to find slope from graphs for a while using the words rise over run. We are still going to be using rise over run kind of for this stuff. It's just going to be a little bit different. We're going to think about it in a little bit different of a way. We're not going to have a visual representation. We're going to have to do more of the calculations ourselves. So we take rise over run still, which is the up or down movement of the graph, as in if it's going up and then over, that would be the rise. The rise would be up. This rise would have been a negative one, a negative rise, so it's going to go down. And then you always run to the right. So if you're rising and then running to the right, that's the numbers you're going to be calculating. If you're going down and then running to the right, that's the numbers you're calculating for slope. Essentially, this means the change in y values, which is the rise. This is what I mean. If I am going up and over on these graphs, I am changing the y values, going up along the y-axis, right? Same thing if I were talking about way over here, I would still be going up and over along. If I was going up, the y values are changing. So if I was really paying attention to the y values of what I was using to go up and over, I would be finding my rise, my change in y values. And then the change in x values comes from the run. So I would have been running this way. If I was rising and then running, this little run right here is a change in x values. So that's what we're going to be finding, because it's going to look a little different now that it's on a table and not on a graph. So if we're looking for the rise and the run of a table, which is change in y values over change in x values, we're going to be looking for the y side and the x side. So since the y looks like this over here, I have visitors at my door that don't know I'm videoing. Sorry, okay. If I have, this is my y side, and I'm trying to see the change in the y values, it goes from 3 to 5, which means it went up by 2. This is my change in y's. And I also can call this my rise. So if you ever have, to memorize that, the y's rhyme with the word rise. But anyways, change in y, which is the rise, over the change in x, which is the run. Okay, same kind of stuff. It's just going to be, like I said, we're just looking at it a little different. And from 1 to 2, it's going up by 1, okay, because 1 plus 1 is 2, right? So if I take the change in the y values, which was 2, over the change in the x values, which was 1, I can now find my slope, which was 2. So we knew how to find a slope. That was 2 on a graph, going up 2 over 1 kind of thing. And now we can find the same type of slope just from a table, not looking at a graph, just by calculating the y and the x values. So let's look at the second example here. Remember, I take the change in the y values, which I can consider my rise, over the change in my x values, which I can consider my run. So let's see what's changing from 10 to -4. Now this is where it gets a little bit tricky, because you might not be able to do this in your mind like I did for 3 to 5 was 2. So you could always use your calculator. And if you're trying to figure out what 10 to -4 is, you would actually do subtraction. Just like we would have done 5 minus 3 to get us 2, we can do -4. Sorry if that's a little bit hard to see. We would do -4 minus 10 to get -14. That is the rise. And yes, it is a negative value, which means that this line probably went down. So if it was rising -14, let's figure out what it's running. Remember, this is the change in x. So the change in y goes on top, and the change in x is going to go on bottom. From 2 to 6, that would be going up 4. And if you don't trust me, 6 minus 2 is 4. So that is why this one is going 4. So I can put a 4 up here, down here. I don't need to put the plus sign because it's positive. We don't put positive signs in front of numbers if we don't need them. -14 divided by 4, or over 4, either way, you can say it either way, reduces down to -7 over 2, and you do need to reduce anytime you can, okay? All right, let's look at this one. So first we do the rise, which is the change in y values, over the run. So whatever number we get for here is going to go up here, from 9 to 8. this was rising. Actually, it wasn't rising, it was going down. It was going down by 1. And if you need to check, let's do 8 minus 9 to see what the answer is, and it is minus 1. So I can put my minus 1 on top. And then the change in the x value, so 4 and 4. I mean, you might be able to see this, but it is 0. So there was no change in the x values. And if I do negative 1 divided by 0, you actually get the word undefined. Oh, darn. Well, you could not see my answers, could you? Sorry. That happens in real life too, but usually people are here to tell me you can't see it. Oh, well. So you will notice that if I put negative 1 over 0, anytime you put anything over 0 in the calculator, you're going to get the answer that says undef, which means it's undefined, which means the lines go straight up and down just like that. All right, so this answer is not 0, it's actually undefined. So I can just go over here and write the word undef, and if you do, we know what you mean undefined. Okay, so let's do a couple more examples, and you might notice that I did not kind of find my pattern. That is kind of what I'm doing, but you have to be careful with tables because sometimes they might skip numbers, kind of like 2 and 8 and 14 and 20. I think that's counting by 6s, but you might find some numbers that aren't counting by a certain number each time, and it gets a little tricky. And it's okay if tables do that. All you need is 2 points. Just like whenever we did the slope on a graph, we only use 2 points to rise and to run. It's kind of the same thing here. We really only need to calculate 2 points. So if we did more than 2 points, it'd just be kind of extra work, and we don't need it, okay? So let's go down to example A. I'm gonna do a few more of these with you, and then you're gonna do you're gonna do some on your own. Side note, I realized that this says 0, 14. You might remember from old pathways that this 14 right here would represent a y-intercept where it crosses the y-axis, but we're not really talking about that right now. We're talking about slope. So let's go back to finding rise over run. Remember, my y side is my rise side. Remember, I'm putting my change in y values, which is the rise, over my change in x values, which is the run. So let's find what is the change from 14 to 8. And I could technically choose any of these two. Like, I could choose any 2 points that I wanted to look from. But I'm just going to go ahead and choose the first 2. So 8 minus 14. I know your initial thought is to take the bigger number and subtract. But if we're finding the difference between the two, we're going to have to take the second y and subtract it from the first y. So 8 minus 14. And that gives us a negative 6, which makes sense because these numbers are going down. We don't have a rise going up. We have a rise going down, okay? So negative 6 is the rise. The run from the same 2 points goes from 0 to 3, and I can tell that that is 3. Negative 6 divided by 3 is negative 2. Do not forget the negatives or you will get them wrong. And remember, this is me reducing, okay? I found the actual answer, what this really means. So that's also part of making sure that you get these right, is you reduce for one and you get the negatives in the right places. All right, let's look at this one. I noticed this goes through the origin. Starts at 0, 0. I think it's proportional. Anyways, let's try to find the rise and the run. So this one would be easy to see from 0 to 8 how much it rises. Looks like it's going up 8. And from 0 to 10, looks like it's going up 10. But just to be, fun or, extra, I'm going to show you what happens if you choose a different 2 points. Not the first 2, but you choose the bottom 2. I'll show you what happens. So the difference from 12 to 20, how far does it change? And it looks like it's going up in numbers, so 12 to 20, looks like it's going up 8. And just to check, I would take 20 minus 12, and yes, it does give me 8. Okay, and then the run over here, 15 to 25, looks like it's going up 10, or running 10, I should say. So the rise is 8, the run is 10, and 8 divided by 10 doesn't do anything perfectly, but it does have a reduced fraction as your answer, 4 over 5. Hold that. There's your answer. All right, let's look at the left, 2 more, and then I'm going to have you do just 2. Actually, I'm going to do just this one with you. You know what? I'm going to do 2 more. Okay, so let's look at these 2. Something I do notice, if you are trying to find the right points, because you could, like I said, you could use these 2 points, you could use the first 2 points, You could use the middle two. You could even use the first and the last, as long as you're using 2 points to find the stuff from. That's kind of the goal here. And you know what I noticed is that there's a lot of negatives up here and there's some positive numbers down here. So I'm going to choose the numbers down here. They probably might be a little bit easier to work with. This is the kind of stuff that you can see kind of before you start really working. So again, let's do the rise first. From -2 to 2. So what I'm going to do is I'm going to say 2 minus -2. 2 minus -2. That's the change in the y values. Gives me 4. And it's a positive 4, so that's good. And then from 14 to 20, let's do 20 minus 14. Oh. 20 minus 14 gives me 6. 4 divided by 6 reduces the fraction to 2/3. All right, and then last but not least, I am going to do this one with you only because I can tell that it's a special case. How much does it rise from 2 to 2? Nothing. It's 0. And from -1 to 3, again, if you don't remember how to do that, you would have to take 3 minus the first one, which is -1, and you get 4. So you might be like, wait, how did 3 minus -1 get you 4? It's because that minus negative right there turns basically into a plus sign. Anyways, the run is 4, so we have 0 over 4. And do not get confused with the other one that we had done earlier with a 0. 0 divided by 4 is 0. So remember, we have 0 slopes and we have undefined slopes. This is a 0 slope. It would have looked like this on a graph. This one was undefined slope. It looked like this on a graph. All the other questions had actual answers to them. I want you to try these two on your own, and we will check them when you're done.